question about and we'll go through whichever one. Okay, so I have these solved already, and I'll talk through them. For number one, it asks you to solve these by substitution. Neither of these are solved for an x or a y, so you needed to solve one of them so that it was solved for an x or a y. I solved for this y in the first equation. You could have solved for any of the x's or y's. You would have had fractions if you didn't choose the one I chose, which is fine. So be careful with those, but you still could have done any of the variables. So I solved for this one and then put this equation back into the second one where y was. Solved for x to get 1. Put that back into this equation and put my y. So my order pair was 1, 2. Do you have any questions on that first one? The second one, you needed to graph both of these lines. One was in slope-intercept form, and I tried to color code these, so this one is in blue. Graph your y-intercept, graph your slope, connect all the points, make sure you extend your line all the way through the graph, and have arrows. My arrows are small, but there are arrows. And then for the other one, it's not in slope-intercept form, but if you knew your slope was -1 and your y-intercept was 7, you didn't have to change it. But if it helps you see it better, I did change it. If your slope was -1, your y-intercept was 7, graph that line all the way through. These two lines are not the same, so they would not overlap and have any solution. They don't have the same slope, so they would not be parallel. And they intersected right here at 4, 3. For number 3, it asks what is a solution and asks you to use elimination. Does not matter which one you chose to eliminate the x's or the y's. However, either way, you need to change both of these equations because you did not have the same coefficient for x or for y. So I chose to get rid of my x's. So I was not thinking when I did this, I think I did it really fast. And I used 6 and 4 to get 24, but the lowest would have been 12. So if you use 3 and 2, that would have worked just fine. If you were getting rid of your y's, 35 is the lowest common multiple, so multiplied by 7 and 5. Really, the multiple or whatever number you multiply to get, that doesn't matter. I could have used 36 or gotten to 36, 48. It doesn't matter. Just the bigger you go with those numbers, the bigger your problem becomes number-wise, so be careful with that. But I eliminated my x's, and when I eliminated my x's and solved for y, I got y equals 2. And then I put y back into this equation to solve for x. And when I solved for x, I got x equals -1. So my order pair was -1, 2. Do you have any questions on that one? Number 4 asks, is this point a solution to the system? So that was like one of the very first things we did when we started this unit, determining if something is a solution or not. Put that ordered pair into both equations for your system and see does it work. If they both work, then it is. If one or both does not work, so it worked for the first one, but it did not work for the second one. So this was not a solution, and the reason would be it doesn't work for both. It doesn't make both equations true. However you want to word that. Do we have any questions on that one? The last problem asks us to write in equation number 1 that would create a system that has infinitely many solutions. Remember that infinitely many solutions has to be the same line. So to determine what that would be, I took the given equation and I converted it into slope-intercept form, and then I copied it again. So these would have infinitely many solutions because they're exactly the same. They're crossing at every single point along the line. In reality, you also could have just wrote anyway, this same equation again instead of converting it, because it still would have been the same. Questions on that last one? Today, well, first, we have now covered all the different ways to solve systems of equations, graphing, substitution, and elimination. Now we're going to take all of those things and apply them in word problems. If you have those notes on your desk, we're not going to solve it before lunch. We're just going to read it and look for important things before lunch, and then we'll continue that after. As we start doing this, the very first problem, we're going to do all 3 ways of solving. After that, we're just going to choose one. And it'll be the same process when you go to take the quiz and test. You'll have the choice of how you want to solve it. Solve each one. So the first problem on your word problem notes, I'm keeping this up because I see some pencils still writing. Read through that. Take a second to read through that. And then we'll talk about what you think is important. On the map, what was your question?
Oh, I just want to know by login.
Really quickly, in this word problem, what things did you find important? With the variables. So when you find something important, circle it, highlight it, underline it. Here they gave you your variables, so you don't need to define them, they're defined for you. Was there anything else that was important, or that you found to be important? $60 of nachos, total of $220. Anything else? Large nachos cost 5, small cost 3. So really any numbers, any variables, any totals. Those are all important. And then what are we looking for? Answer that question when we come back from lunch. Alright, in this word problem, what are we looking for? What is it asking for? To do what? To model it to find what? There we go. That was the answer I was looking for. Alright, so anytime you get a word problem, circle, highlight, underline, anything that you find important, numbers, variables, what it's asking for. If it gives you variables and defines those variables, you don't have to make up those definitions, but you do need to write those down. So let's do that. L is the number of large macros.
Oh, can you scroll up a bit? Thank you.
And S is the number of small passive macros. There's like two roller coasters coming together. I'm not gonna fix that. It's gonna bother me though. Or after we find the variables, we have to come up with two equations to make this system. Here they give us 4 different numbers. 2 of those are your totals. One tells you total of 220. What is the other total number? The 60 and 220 are both your totals for these two systems of equations. So we know that much. We can start there. And we're going to write these two equations. So 60 is the total number of nacho packs altogether. We need something that also represents number of nachos. What represents number of nachos? Oh. That's the total number, yes. What else tells us number of nachos? S and L. They both tell us number of nachos, just different types. So since these both represent the number of nachos, and 60 is the total number of nachos, we're going to add L and S to this. We don't know what those are, but if I knew what L was and I knew what S was, I could add them together and they would equal 60. For our total cost of 220, or total, whatever it said, we need the cost of the nachos in addition to the number of nachos. So we're going to be multiplying the number and cost together. How do you think we would write that second one? Anyone want to take a guess?
I
We're going to multiply the not L and S together. How much do the large nachos cost?
don't know.
5. So we're going to multiply 5 times L. And finish the rest of this. Plus 3 times X. If we knew the total, if we knew the number of nachos, we know their costs, then multiply those together, the number of large nachos and its cost, and the number of small nachos and its cost, and then add those two together, we would get the total cost. So we have our variables, we have our equations. Now that we have those things, we can solve. So like I said before, we're going to solve this one all 3 ways by graphing, substitution, and elimination. Then after that, we'll just, choose one. If you do not have your calculator, go grab it, because the first way we're going to solve is by graphing. Alright. To solve this by graphing, clearly our variables are not x and y. To graph this in your calculator, and if you're using Desmos to practice like at home, you need variables x and y. So what I'm going to do is just change my L's to be x's and my y's or s's to be y's. It really doesn't matter which one you make which one, as long as you keep it consistent. If you want to make your s's y, that's fine. Just be consistent. We would need to convert both of these to slope-intercept forms. I'm going to rewrite them first. So I would need to solve both of these equations, get it in y equals mx plus b. The first one would be y equals negative x plus 60. Just subtract x. The second one you would need to do a little bit more work for.
So should we be taking this
Writing this down. I would leave all of these as fractions, whatever they are. You don't need to simplify it. Once you have both of your equations on your calculator, you're going to go into your y equals. And type these both in. Negative x plus 60. And negative, use your alpha y equals to get your fraction. 5/3 x plus alpha y equals again. Y equals Once you have both of these in your y equals, you're going to hit graph so you can see them.
Yes.
And then graph. Now, when you hit graph, your lines may not show up because it might be outside of, one of them is like 220 divided by 3, whatever that number is not going to be in this 10 by 10. So if you go into Zoom, and then look for Zoom fit, you'll see the lines, but not necessarily where they intersect. So to actually find that, I'm going to zoom out again. So zoom and then zoom out. And press enter. And now I can see where they intersect. Again, yours are not colorful like mine, so it'll look a little different. And then to find the intersection point, you're going to go into your Calc menu, second trace, and hit intersect, because we need to find that point. It's going to ask for the first curve. Your cursor should be on one of those. It is, so I can hit enter. And then I'll ask for the second curve, and your cursor should be on the second line. In my case, it is, so I can hit enter. It'll ask if you want to guess, that's if you want to move your cursor where the two lines intersect. You don't need to do that part. You can just hit enter again. And it will tell you what that intersection point is. 20, 40. And once you have your intersection point, you have to go back and bless you, put it into context. So you have to remember what your x was, what your y was. Well, our x's was L, our y was S. So our L had 20 large packs of nachos, and our S had 40 small packs of nachos. So if you were solving by graphing, I would need to see you define your variables, set up the equations, solve the equations so that they're in slope-intercept form, tell me the intersection points, and then rewrite them so that it's in context with the problem. What do those things actually mean? Like I said earlier, you're going to have a choice of how you wish to solve these. So we're going to continue with this one and solve it by substitution and elimination. But before we do that, does anyone have any questions on how we solve this by graphing? Marta? On a different line. So somewhere where you have space, write the equations again. The L plus S equals 15. And 5L plus 3S equals 220. Okay. The next way we're going to solve this is by substitution. So here it does not really matter whether we solve for L or for S first. We're going to end up solving for both. But in order to solve for substitution, one of these needs to be L equals or S equals. So we can pick one. Let's say I want this to be S equals. So I would solve this for S, move L to the other side. And since we're solving this by substitution, we're now going to take this equation, the 16 minus L, and put this back into the other equation where S is. So this would be 5L plus 3 times 16 minus L equals 220. From there, we could solve for L. And my terms. This will give us 2L plus 180. Subtract 180. Notice that we got the same answer. We should have gotten the same answer. So if you were unsure of did I do this correctly, you could solve it one of the other ways and see did you do the same thing. If not, something's wrong with one of the ways you solved it. We could put this back into our equation for S to find what S is. We would get the same answer we got before. Do we have questions on how we solve this by substitution?
What's that? The little teardrop thing you asked. It's just weird.
Sometimes my letters connect. I try to write in manuscript and cursive at the same time, and then it looks like whatever I just wrote. Okay, some of you have space. Rewrite them one more time. We're going to solve them by elimination.
No.
It does not matter which one you get rid of first. You'll have to change both equations either way because the coefficients for L and for S are not the same. Do we want to get rid of L or S? L, okay. So if we get rid of L, we would need to multiply this to be the same coefficient. So multiply everything by 5. That would give us 5L plus 5S equals 300. Now that our coefficients are the same and they are both positive, we will subtract. 5L minus 5L gives me 0. 3S minus 5S gives me negative 2S. 220 minus 300 gives me negative 80. As you're solving these problems, if you end up with a negative somewhere, something is off. You forgot a negative somewhere, didn't divide both sides by the same negative, something. Because your word problem should not give you negative values. You should have positive values. Once you find one of them, or in our case S, we can go back and find L, put it in either of these equations. I'm going to put it back into the L plus S. Now we have any questions on any of the different ways we solve this part?
What was going to give us in real life versus the practice?
That would be like if you actually wanted to compare, you might, but not normally. We're gonna do one, but you might, I don't know. Yeah.
What's the last one called?
Elimination. Find this next example. It's not example 2, it's example 3. Take a second, read this, and then we'll find anything that is important. I have extras. No, it's okay. What is important in this? Okay. 5 pairs of earrings, 2 pairs of shoes, for $30. Marta? Okay. Each pair of shoes costs $2 more than 4 points of positive.
No one would put that in writing unless they were absolutely insane.
Anything else important?
Who's the constant?
They tell us what our variables are, so we don't need to make them up. What are we looking for? Notice how those go together. We don't know what the cost of earrings and shoes are, and we're looking for the cost. Anytime we look for something or don't know what something is, those are going to be your variables. We'll do some examples where we're not given the variables. That's why I'm saying that. Okay, so putting what we know, We know that E is the cost of earrings and S is the cost of shoes, so we can write that down. That says earrings, because the pen is not working. More specific, cost of a pair of earrings, cost of a pair of shoes, if you wanted to. In this one, they do give us one total, that's 30. We know one of our equations are going to equal 30. How do you think we would rate that one? Not quite, because that would just be if I bought one pair of earrings and one pair of shoes. Or how many of each did I buy? 5. So 5E and 2S equals 30. But for the other one, or for our other equation, this is right here, each pair of shoes costs $2 more than 4 times the cost of earrings, is going to be our equation, but it's going to be written a little differently. Because this is talking about how much the shoes are compared to the earrings. So since it's talking about the shoes, we can say the shoes equal, or the cost of the shoes equal. So we can start this off. So with a question like this, where there is a variable already set up, this is a good substitution problem. It does not mean you couldn't solve this by graphing or substitution elimination. But since this is already an S equals, why not just continue and solve it like that? So I'm going to take this and put it into the other equation where S is.
That's not.
And then from there we could solve for E. So 5E plus 4 plus 8E equals 30. Combine your E's, so 13. And solve for E, 4 on both sides. And divide both sides by 13. Remember your units, here we're looking for cost of, so our units are going to be dollars. You can take the earrings around sale. So once we find E, we can go back and find S. Put E back into our equation for S. And figure out what that is. Again, maybe these shoes are on sale, I don't know. So our final answers would be earrings cost $2, shoes cost $10. Because you're doing a lot of work, box in your answers at the end. That way I know, box in or circle, underline, something like that. So I know this is the end of your work. Yes, Cody. The only time you would need to do that is if you are solving it in general. Like, it wasn't a word problem. Questions on that one? There are so many examples that I gave you for practice. We're not going to go over all of them, it will take too long. But I do want to touch on a couple. So find the page that looks like this. That talks about flying, going down a river, should be after the maze. We're going to do one of these by elimination and one of these by graphing, so we'll come full circle and solve everything at least once or twice now. Okay. And this first problem, this says flying with, I'm just going to read it. Flying with the wind, a plane went 369 miles per hour. Flying into the same wind, the plane only went 325 miles per hour. Find the speed of the plane in still air and the speed of the wind. Important things here. When the plane is flying with the wind, it was 369. When the plane is flying into the wind, it's going 325. And then in this last part, it tells you that we need to find the speed of the plane in still air and the speed of the wind. So the two things we need to find are the two things we don't know. The two things we don't know are going to be your variables. So the speed of the plane in still air would be really just the plane's speed. So I'm going to say P equals the plane speed. And then the speed of the wind would just be the wind speed. You can use P and W as I did. You can use X and Y. It really does not matter. So here is some background information that you may not have known. If the plane is flying with the wind, that means the wind is kind of pushing the plane, helping it along, which is why it's going a little faster. So if it's pushing the plane, we're going to add those together, whatever the plane speed and the wind speed is, R, to get that number. So I can say P plus W equals 369. If a plane is flying into, in this case, the same wind, it's going against it. It's not getting that same push. So because it's now not getting that same push, we're going to subtract that wind, minus W, which is why it's going a little slower. These equations or these problems are really good elimination problems, but that doesn't mean we can't solve it other ways, which we'll see when we do it by graphing. Does not matter what we eliminate first. I'm going to go ahead and get rid of my W's. So I have a positive and a negative. So I'm going to add those two equations together. I have 2p plus 0 equals 600. divide, and substitute. When you're doing these problems, your plane should be faster than the wind. If you mix up something and your wind is faster than your plane, unless this is like an extraneous case, like a tornado or a hurricane, that really shouldn't happen. Your plane should be going faster than the wind. What was that? 347. Thank you. And then our units would be miles per hour. Then we can go back and find our wind speed. Put this into either equation. I'm going to put it into the first. Assuming all of these are normal situations where the plane is going faster than the wind. Any questions on how we solved that or got those answers? Together, I'm going to talk through some of this language and then I'll let you guys practice. So number 2, I'm going to go ahead and read out loud. Going down the river, a boat went 13 kilometers per hour. Going up the river, it only went 3 kilometers per hour. What is the speed of the current? How fast would the boat go if there were no current? So important things here. When we went down the river, the boat went 13. When we went up the river, the boat went 3. It's asking 2 questions. What is the speed of the current? The current is the river. The river is flowing. And then how fast would the boat go if there were no current? That would just be the boat's speed. So our 2 things we don't know, the speed of the current and the speed of the boat. Those are going to be our 2 variables. I'm going to use B and C for boat speed and current speed. Current meaning the river, not what the boat's current speed is. Try not to confuse them. Anyone want to take a guess as to how we would set these 2 up? Let's see, equals 13. What about the second one? Minus C equals 3. Yes, Cody. We're gonna graph, yes. Yes, we're gonna graph. So I'm gonna change all this in a second. Because these numbers are small enough, if you wanted to, after you solve them both, you could graph it like actually on graph paper. I have a graph paper, you can graph it on by hand. Or you can still use your calculator. It's either or. Okay, so these are kind of opposites. Going down a river would be faster, so you're adding, the current is helping the boat along, it's pushing it along, so you add. We're going up the river, you're going against it, so it's no longer helping, so you're subtracting that help. We're going to graph both of these. I'm going to change these to X and Y. And that's you were asking about this? Yeah. About how to do this in the calculator. That's what I'm up there. So solve both of these, get them both in syllogistic form first. I'm going to rewrite them before I do anything. So the first one would be y equals negative x plus 13. 13 minus x. We would need to subtract this x and divide. Y equals positive x minus 3. Once you have your two equations on your calculator, go into your y equals and put those two equations. Negative x plus 13 and x minus 3. And also the same approximation. Once you have those two equations hit graph, you may need to fix this. If yours did what mine just did, go back into Zoom, go back into fix. Go back to the first y equals. It's negative x plus 13 and x minus 3. I hit the wrong one. Zoom, whatever I just said, you can see it, so it doesn't need to be like zoomed in, so this is fine. But if you wanted it more zoomed in, zoom standard, I think is what I was actually looking for. Yeah. Yes.
This is wrong.
You probably put in the minuses. So if you want it zoomed in like this, go zoom and then standard. That will get the 10 by 10. And here I could count it. But maybe my eyes are off, and maybe I think this one, double check, make sure this is exactly the point I think it is. Then you could use your calculation, so second trace, intersect. Now, right now it says first curve. I see mine is blue, but I don't see my cursor. You don't really need to see it, but if you wanted to, you would just move your arrow until I just kept pressing right until it came into focus. So now that I see this is actually on my blue line, I can hit enter. And now I see my cursors on my second line or my red line, so I can hit enter again. Yes. I don't want to guess, I want my calculator to do the work. I'm just going to hit enter again. And it will tell me that they intersect at 8.5. So I would write that down as my order clear. and then write what those really mean. X was B, Y was C, so B equals 8 kilometers per hour, and C equals 5 kilometers per hour. I don't know what type of boat this is, but they're not going very fast. Do we have any questions on that? I know we don't have a whole lot of time left, but use what time you have to practice. You have so many different practice problems in those notes. You can go back to the first couple of examples, more of these. Really quickly, most of these have the same sort of language: up the river, down the river, with the wind, in the wind. With the current would be adding, against would be subtracting. You might see something like with a tailwind, that's like the wind is pushing the tail of the plane, so adding. And then return trip, flying back into the same lane, so against. If you're not sure, you can ask, but one should be adding and one should be subtracting each time. Right? You guys have this time to work. Let us know if you have any questions.